K-Tutorial 4 Designing in ++, Lesson 2. To prepare for the semantics of threads and local variables, in this lesson we split the state cell into an environment and a store. The environment and store will be similar to those in the definition of lambda++ in Tutorial 3. This configuration refinement will require us to change some of IMP's rules, namely those that use the state. To split the state map, which binds program variables to values, into an environment mapping program variables to locations and a store mapping locations to values, we replace in the configuration declaration the cell state with two cells, an environment cell and a store cell. Structurally speaking, this split of a cell into other cells is a major semantic change, which, unfortunately, requires us to revisit the existing rules that use the state cell. One could, of course, argue that we could have avoided this problem if we had followed from the very beginning the good practice style to work with an environment and a store instead of a monolithic state. While this is a valid argument, highlighting the fact that modularity is not only a feature of the framework alone, but one should also follow good practices to achieve it, it is also true that if all we wanted in Tutorial 2 was to define IMP as is, then the split of a state in an environment and a store is unnecessary and not really justified. The first rule which uses the state cell is the lookup rule, which we modify as shown. So we first match the location n of x in the environment, then the value I at location n in the store, and finally we rewrite x to I into the computation. This rule also shows an instance of a more complex multiset matching, where two variables, x and n, are matched each twice. The assignment rule is modified quite similarly. The variable declaration rule is trickier though, because we need to allocate a fresh location in the store and bind the newly declared variable to it. This is quite similar to the way we allocated space for variables in the environment-based definition of lambda++ in Tutorial 3. The side condition, fresh n nat, generates an element of sort nat that has not been generated so far. We quoted element because, like also explained in the lambda++ tutorial, technically it is nothing but k syntactic sugar for a straightforward operation. It generates a term of the form sim_nat of n of sort nat, where n is a natural number, thought of as the nth symbolic natural number that had been generated so far. The counter n is maintained in a cell that the k tool automatically adds to the configuration for this purpose. Compile and krun sum.imp to see how the fresh locations have been generated and used. There are two fresh locations needed for the two variables. Note also that a cell holding the counter has been added to the configuration. In the next lesson, we will add the semantics of variable increment and see how that yields non-deterministic behaviors in programs and how to explore those behaviors using the K tool.